Okay. Hapo na hapo. Tena watu wengine bwana. Watu wanaingia kwanza kitu bila kana ni oh, bila kana expire. Ndio zinaona kama. Ndio zinaona pale. Mara kwa SALTS.
Simama mbele ya kamera.
Nobody ngoma hata leo.
Watu bado hawajakuja.
Ndio. Hizo mambo nataka kuona ile light soma mali kuna hizo SALTS naona kama nataka kama itazuia.
Simama mbele yake.
Kwa hiyo SALTS songa. Angalia kamera ndugu yangu. Songa tena. Hebu kuja hapo. Unaangalia kama hiyo ni itanikata kichwa. Nimekata kichwa? Wapi?
Kukata kichwa aje? Kichwa yako sinaonekana.
Nasema yote inaonekana yote. Haikati.
Mimi ndo mrefu.
Sawa. Utakuwa unaniangalilia. Ni wangapi? Kama watu wameingia. Bado hebu nione nini. Bushi ni mbona na wafahamu. YouTube. what you give wrong.
Ukienda hapo sasa utaona endelea kuona
Hiyo mwangaza bwana. Na ningezima.
hebu kulia washa
Na change kubwa sana.
kuandika
Andika sindio, lakini unaniona vizuri, right?
mbona kwa
So salts, and we say a salt is a substance. A salt is a substance formed when an hydrogen ion in an acid is replaced fully or partially by a positive cation. So that is the definition of the term salt. Definition of the term salt. As per the definition, you can find that when replaced by a cation from an acid, so to mean that all the acids they have a hydrogen ion. For example, let's look at the examples of acids. Examples of acids and acids. We have hydrochloric acid, we have sulfuric acid, we have nitric acid, etc. So you've noticed that all the acids they have a hydrogen ion. So when this hydrogen ion is replaced by a positive cation, now the compound we get is what we call the acid. For example, when you react magnesium, which is a solid, you react with hydrochloric acid, HCl is aqueous. The product you get is that magnesium will replace the hydrogen in the hydrochloric acid, and the compound to be formed will be magnesium chloride. It appears, then we have hydrogen gas to be formed. So this is now what we call salt. That is what we call salt. It has been formed after we have replaced an hydrogen from an acid. Next thing we are going to do is the types of salts. And we have four types of salts. So types of salts. So number one, we have normal salt. Number two, we have acidic salt. Number three, we have basic salt. Then finally, we have the double salt. So those are the four examples of salts. We have, and Let's do it that way. You can see? That's all. Right. So, those are the 4 examples of salts. The 4 examples of salts. And the definition of the first is salt, which is the normal salt now. Normal salt. So the normal salt, these are type of a salt which has no replaceable hydrogen ion. It's a salt that has no replaceable hydrogen ion. Hydrogen ions. The good examples for the normal salts, we have sodium chloride, we have magnesium sulfate, we have calcium nitrate. So those are good examples of the normal salt. They are good examples of the normal salts. The other salt is acidic salt. Acidic salt. Acidic salt, and the definition of the acidic salt, we say that it's a type of a salt. It's a type of salt that has replaceable hydrogen ion. This type of salt, the acidic salt, is a type of salt which has a replaceable hydrogen ions. And the good examples of this one, we have sodium hydrogen carbonate. Sodium hydrogen carbonate. We have potassium hydrogen sulfate, etc. So you find that these are salts. Remember, when we define salt, we say it's a type of a salt which the hydrogen ion can be either wholly or partially replaced by a positive cation. So there are some hydrogen ions which will be replaced wholly, and some others will remain in the compound. So these are good example of definition in that case of the hydrogen being not replaced fully. The other salt is the basic salt. The basic salts, and these are the types of salts which has the hydroxyl ions. They are salts which has the hydroxyl ions. Basic salts. Basic salts, we say it's a type of a salt. It's a type of a salt. It's a type of salt that contains hydroxyl ions. So these are the type of them. When you test them, they have the pH. It's after 7, which is the neutral. So it means it has alkalinity characteristics. Just alkalinity. So it means it is basic, simply because of the presence of the hydroxyl ions. Good examples for this one, we have the basic magnesium chloride. Examples, we have basic magnesium chloride. Basic magnesium chloride. The chemical symbol for that is MgOH-Cl. That is the basic magnesium chloride. Another example is basic lead 2 carbonate. Basic lead 2 carbonate. Basic lead 2 carbonate. This is how it is written. PbOH, it has a balance of 2, so it will change with the hydroxyl to have 2. Then we have now the lead, you have a dot there, carbonate. Simply lead has a valence of 2, the carbon has a valency of 2 as well. So that is basically a 2 carbon. The last one is the last example of another type of a salt is the double salt. The double salt. Let's create some space. We have the double salt, and the double salt, it is a type of a salt. It's a type of salt that contains two different anions, that contains two different anions and cations. So it is a type of a salt that contains two different cations and anions. When you talk of anions, these are negatively charged ions. The cations, they are positively charged ions. A good example for this one is trona. Example, we have trona, and the trona, this is how it is written. Sodium hydrogen. That is the compound called trona. It is made up of sodium. We have hydrogen ion. We have carbonate ions. We have 2 atoms of sodium. We have carbonate as well. So those are the type of the examples of. So we have some other examples. We have trona. We have hydrated potassium aluminum sulfate. The examples: hydrated potassium, aluminium, aluminium sulfate. Aluminium sulfate, read this way: Kal sulfate, then we have 12 molecules of water. So that is a compound which contains both the cations and anions. The next bit we are going to do is the solubility of salts in water. Solubility of salts in water. Solubility of salts in water. Solubility of salts in. So we're going to look at the different types of the salts of the sulfuric sulfates, the salts of the chlorides, the salts of the nitrites, the salts of the carbonates. So we are going to form different types of the salts. Then we have a table like this one. We have the sulfate, we have chlorides, we have nitrates, then we have carbonates. Then here we have cation. or sulfates. So solubility of salts in water. Solubility of salts in water. So we have the column of the cations, we have the column of the sulfates, column of the chlorides, column of the nitrates, the carbon there. So the sulfates of sodium, we say it is soluble. So the tick represents the solubility. Is soluble. This one is not soluble. Right? So sodium sulfate, for the sulfates, you find that sodium, potassium, ammonium, magnesium, aluminium, zinc, iron, not iron, yes, iron, then we skip lead, go to copper, then we skip barium. All of them, they are soluble. So we can summarize this one and say all sulfates are soluble in water except calcium, the salt of the sulfate of calcium, lead, and barium. When we get to the column of the chlorides, you find all of them, they are soluble except for the copper, for the lead, which is slightly soluble, but generally we say the salts of chloride salts, they are all soluble except the lead, which is slightly soluble. The salts of nitrates, we say all of them, they are in water. For the carbonates, only the first three, and these are according to the reactivity series. So we have potassium, sodium, and ammonium, the salts of the carbonates of sodium, potassium, and ammonium. They are the only one which are soluble in water. The rest, they are not soluble in water. The next bit we are going to handle is the methods of preparing salts. Methods of preparing salts. Now we are getting into the topic now. Methods of preparing salts. Methods of preparing salts. So one of the methods which is basically used to prepare salts is the action of the acid on metals. Action of acids on metals. Action of acids on metals. And you find that when you react a metal, when you have a metal, you react with an acid. The product you get is a salt and a gas which burns the pop sound. Remember, hydrogen gas. So when you react a metal with an acid, the product you get is a salt. So in that case, it is a method which is used to prepare salts. The gas which is formed, it is tested by a burn splint, but it produces a pop sound when it is reduced to a burn splint. Some good examples, we have magnesium. You react with HCl, hydrochloric acid. The product you get is magnesium chloride. plus hydrogen gas. Plus hydrogen gas. When you react lithium metal, it's a solid, you react with carbonic acid. The product you get is lithium carbonate, lithium carbonate, you have two there, then hydrogen gas, hydrogen gas. Another example is the reaction of aluminium. You react with the nitric acid, which is aqueous. The product you get is aluminium nitrate. Aluminium nitrate, this one is 3. So we have 3, but 3 is aqueous. Then we have hydrogen gas. So those are some of the examples showing how the acids can be prepared by the action of acids on metals. Action of acids on metals. Another method of preparation of acids is the reaction of acids with bases. Reaction of acids with bases. And in this case, we're talking of the insoluble bases. So reaction of acids with insoluble bases. With insoluble bases. The good example of insoluble base is copper 2 oxide. Copper 2 oxide. It's a base. When you react this base with an acid like sulfuric acid, the product you get is copper 2 sulfate, this way. Then we'll get water. Remember, the liquid you are forming here, which is colorless gas, liquid, it is tested by this compound known as copper 2 sulfate. Actually, the test for the water, we use the anhydrous when it is white. When you add the drops of water in the crystals, which is white, it changes to blue. And that's the component test of water. The other example of conformation of water is what we call the cobalt 2 chloride pepper, which is blue. So when you dip that pepper in water, it changes to pink. It changes to pink. So that's like component testing for water. And number 3, other method which can use to prepare salt is neutralization. Neutralization. And the neutralization basically means you get an acid and then you react with a base to get a compound or other solution which is neutral as far as the pH is concerned. So neutralization, it is the reaction between acid plus base. The reaction between acid and a base. So for example, when you react the Cl, hydrochloric acid, with sodium hydroxide, the product we get is sodium chloride. Then we get water. So these are an acid, these are a base. So the reaction is what we call a neutralization. All right. Another example is sulfuric acid. So 4, which is aqueous. You react with potassium hydroxide. The products are potassium sulfate plus water. The other example for preparation of soluble salts, the last one now, is the reaction of acids with carbonates. Reaction of acids with the carbonates. Last example is reaction of acids with carbonates. Reaction of acids with carbonates. Remember, when you react carbonates with acids, we usually get a colorless gas, which changes the lime water to form a white precipitate, and that gas is carbon dioxide. We get colorless liquid, which changes anhydrous copper 2 sulfate crystals to blue, which is water. Then now we get the salt. So basically, acids plus carbonates, you get salt plus water plus CO2, carbon dioxide, plus carbon dioxide. So let's get an example of an acid like phosphoric acid. Phosphoric acid, you react with like sodium carbonate. Solid. So the compound you get is sodium phosphate. Then you get CO2, and you get water. You get water. Another example is nitric acid. Nitric acid, you react with calcium carbonate. The product you get is calcium nitrate, that way, plus H2O plus CO2. So those are some of the examples which you can use to prepare a soluble salt. The last example is the preparation of insoluble salts. Preparation of insoluble salts. And the preparation of soluble salts, the only method you can use is the precipitation method. So preparation of insoluble salts. Preparation of insoluble salts, and we say insoluble salts, the only method we can apply here is what we call the precipitation. The precipitation method. And the precipitation method is a method whereby we react to two compounds which are cations to form, and which are soluble, to form insoluble compound on the other side. And this case is whereby we usually have the spectator ions, and it normally cancels the spectator ions to get what we call the ionic equations. So we say the precipitation reaction. These are the reaction in which solids are formed from aqueous solutions. And the solids formed, we call them, they are called precipitates. And the precipitation reaction are suitable for preparing insoluble salts. We just need to go through some examples here. Examples. Let's react barium nitrate. Barium nitrate. You react with zinc sulfate. Barium nitrate, you react with zinc sulfate. These are aqueous solutions. When you react barium nitrate and zinc sulfate, the barium replaces the sulfate in the zinc compound, and we get barium sulfate, which is solid. Then we get zinc nitrate, zinc nitrate, which is aqueous. So when you react these two compounds in soluble compounds, you normally get one compound which is soluble, which is a solid, and then aqueous solutions. The next step we do, we deduce the ions present. For example, for the barium, the ions present here, we have barium ions, and we have nitrate ions. There are two of them, so we do that. Plus, for the zinc sulfate, we have the zinc ions, and we have sulfate ions. All right. So all of these are aqueous. Remember, these are aqueous in ion anyway. The product, we usually don't have free ions in the solids, the gases, and the concentrated compounds. So for this one, to mean the way it is, barium sulfate, which is a solid. Then for zinc nitrate, remaining with zinc ions, and then you have the nitrate ions. Nitrate ions. All right. So what we have done here, we have introduced the ions present in these aqueous compounds. The next step we do after we introduce the ions present, we cancel the spectator ions. And the spectator ions, we say the ions which occur in the reactant side, and as well they occur in the product side. So you find that like zinc ions, which appears there, and then we have zinc ion there, so it cancels that way. Again, we have the nitrate ions there, we have the nitrate ion there, so they cancel that way. So the ions which they repeat themselves in the product side, you cancel. So after that, now you write now the ionic equation. The ionic equation. Now ionic equation is between barium ions, you react with the sulfate ions, and the product you get, it is the barium sulfate, which is a solid. So this one is the insoluble salt. That's insoluble salt. All right. So that's the step we usually follow to prepare the insoluble salt. The process we have said is called the precipitation. So that's the first example. Let's have another example. So let's get some space. The example is between lead nitrate, which is aqueous, and we react with potassium iodide. Potassium iodide is okay. Potassium iodide, which is aqueous as well. So let's see the product you're going to get. Lead, when you react with the potassium iodide, the lead nitrate, the lead displaces the potassium. So it forms lead iodide. And we have two there, and it is a solid. Lead nitrate, then we get the potassium nitrate now. Potassium nitrate, which is aqueous. So after now we write the equation that way. The next step we do is we introduce the ions present in the aqueous solutions. So for the lead nitrate, we have the lead ions, it's a positive ion. We have the nitrate ions. All right. For the potassium iodide, we have the potassium ion, and we have the iodide ions. Then remember here we don't have the free ions simply because it's a solid, so it needs to be the lead iodide. The two there is a solid. Then here we have the potassium ions. Then we have the nitrate, ions. The next step we do is we cancel the expected ions. And as we have said, the expected ions, they are ions which appear both in the product side and in the reactant side. So for example, we have the nitrate ions. It appears in the reactant side, and as well it appears in the product side. That's how we cancel. We have potassium ion. We cancel potassium ions. We cancel in the product side. So now the ionic equation, which will lead us now to forming our salt, which is soluble, it is between the lead ion plus iodide ion, and you get lead iodide. So this is now what we call the insoluble salts. Insoluble salts. The last example we are going to do under the preparation of soluble salts. Example we are going to have is between the silver nitrate and the sodium chloride. Silver nitrate react with the sodium chloride. Silver nitrate, of 2, so we have a bracket there. We have, so silver nitrate, you react with silver has a valence of 1, it's group 1, a valence of 1, right? React with the sodium chloride, so the product we get is the silver nitrate, the silver chloride, beg your pardon, it's a solid, then we get sodium nitrate. Sodium nitrate, that is an aqueous. That's an aqueous. So the next step we do, we cancel the spectator. We reduce the ions present in the aqueous solutions. So we have the silver ion, we have the nitrate ions, we have the sodium ions, we have the chloride ions. Then we get a solid here, which is silver chloride, is a solid. Then we have the sodium ions. Then we have the nitrate ions. Now let's cancel the spectator ions. We have the nitrate ions in the reactant side and as well in the product side, so we cancel that way. And then we have the sodium ions, sodium ion there. So ionic equation between the silver, you react with the chloride ions, you get the silver chloride, so solid. This is now the insoluble salt. Insoluble salt we are preparing. So that's all about the preparation of salts. Up next, I'll be doing gas laws, and that is from 10 p.m.